Hello everyone. Now let's move to our next part of this UART series. So in this last video we explained about the what is the basic overview of the protocol. In this video we will study this. We will start our main topic, that is UART protocol. So UART means Universal Asynchronous Receiver and Transmitter. So what is the asynchronous? Let's answer this question. What is the synchronous and asynchronous? See, this is the diagram for this synchronous and asynchronous. Synchronous means if there are some devices or blocks which are using same clock, means they are operating on the same clock frequency. Then we can say as a synchronous device or synchronous module, right? And asynchronous means if you can see this first diagram, there are three blocks. Here first block is using this clock, right? Second block is using Q1 clock, okay, and third block is using clock as a Q to output as a clock, right? So here each block is using different clock. So this we can say as a asynchronous, right? And here each block is using same clock, so we can say as a synchronous. So this question is important because in most of the interview they will ask this basic question. So please make the note of this, okay? Now let's move to the UART. What is the definition of UART? UART is a hardware communication protocol used for the serial data transfer between two devices. Means there are two devices, master and slave. So what is the master and what is the slave? We already studied in the last video, right? So the communication, how the communication happen between the master and slave. For that, some protocol is needed, right? So while sending the serial data, we use the UART protocol. Okay. So here we can use this UART protocol. While sending the serial data between the two devices, we can use this UART protocol. Okay, so this is the basic definition of the UART. Now let's move to the next part. Now let's study this working principle of the UART. See, a transmitting UART converts parallel data into the serial data stream and send it over a single wire. So here transmitting side, what is happening? It will take parallel data. So from where this parallel data is coming? Let's take, you have one device. This is taking the data from the memory. So how that data will come? It will come parallelly, right? There may be some bus from memory to that transmitter, right? So it will take data parallelly, and then what UART part means master. What it will do? It will convert that parallel data to the serially and transfer on the single wire, and then it will transfer to the receiver side of the slave, right? So in this way, this UART protocol will work. So in this, here it is mentioned, a receiving UART receives the serial data and convert into the parallel format. So what is happening here? Receiver take the serial data and again it will convert into the parallel format. Okay. Transmitter what is doing? It will take parallel data and convert to the serial. Receiver what is doing? Taking the serial data and convert back into the parallel format. Okay. And then it will transfer. It will send to the other other peripherals or somewhere. Okay. Here, since UART is asynchronous, there is no common clock signals. Instead, both devices agree on a specific baud rate. So, as UART is asynchronous means there is no common clock, right? So, as there is no common clock, then how both devices will operate properly? That is an important question, right? So, let's take the one example. We have two devices. One device is operating on a frequency of like 100 megahertz, and other device operating on the 10 megahertz, right? So both are having different frequency. So it is difficult to transfer or send the data from that device, first device, to the other device, because both are operating on the different frequency, right? So we can't transfer data on that particular scenario. So, and as this UART is asynchronous, we don't have common clock. So what we can do? Instead of this clock, we can use some baud rate. Baud rate means we can say the data transfer rate also. So both will operate on the some particular data transfer rate. Okay. So in that way they can operate easily. So here I have shown in this diagram how this parallel data. It will take this device 1. It will take some parallel data and it will transfer device 1 to the device 2 by serial way. Okay. And then device 2 convert this serial data to the again parallel format and it will give to the other, like a receiver or somewhere. Right? So this is the block diagram. Now let's study what is the baud rate and bit rate. Baud rate means number of signal changes per second, or we can say number of symbol transmitting per second. Okay, transmitting or receiving per second. Okay, and bit rate means number of bit transmitting per second. So in UART, one baud rate is equal to one bit rate per second. Okay, so here why this is happening? One baud rate is equal to one bit rate, because here each symbol is having one bit, means each symbol bit is 1, so that's why one symbol per second or one bit per second, both are same. So that's why here one baud rate is equal to one bit per second. Okay, so this is also important question. Some interviewer maybe ask this baud rate and what is the bit rate. Okay, so please make note of this. And here transmitter and receiver must use the same baud rate for reliable communication. So to operate both devices properly, we need to use the same baud rate. Otherwise, we can't transfer and receive data properly. Okay, so they should have a same baud rate. If baud rate mismatch happens, means there might be data corruption can occur. Okay, there are some standard baud rate also there, like 9600, 19200, and 1,15,200. So those who work, EC students, those who work on this some boards, they might have gone through this baud rate. While using any device, we need to choose one baud rate, right? So they know these things. What is the baud rate? Okay. Next is how the connection between the two UART devices. So here this is one UART device, this is another device. Okay. So this device can be transmit data and other one can be receive data. Okay. Or else UART2 means this device also can transmit data and this one first one can receive data. So in this way there is the connections between the two devices. Okay. Now how the transmission process is going on. So first understand this frame of UART. So in this frame there is a data. Here data is there. Before means they will not transfer direct data. Okay, in UART direct data can't transfer. So what we can do, we use the first we use start bit before data, and after that first start bit, then data, then parity bit, then stop bit. So we have data, we need to add start bit initially, and then at last parity bit and stop bit. So in this way we can this is the frame of this UART, right? What is the use of start bit? It is start of the transaction. Okay, and stop bit means stop the transaction. Parity bit means to check our data is correct or not. See, if start bit if 1 or 0, I will explain in this in the Verilog code. Based on the start bit means it is 1 or 0. Receiver will check and then it will respond, means the data data should come or not. Okay. Similarly, based on stop bit, at what time the data receiving the data should stop, that will detect by this stop bit. Okay. And this parity bit is used for the checking the whatever the data you are sending, it is correct or not at the receiver side. That we can check by the parity bit. Now let's take one example. If you transmitted data like 10110 and what we received 10111. So here data mismatch is there, right? So it's here 10110 and here 10111. So one bit data mismatch right here. So how we can check? What we can do? We can while transmitting we check this data and we do some parity checker. We use some parity checker and whatever the result we will show in this parity bit. And the receiver side again whatever data we will receive we will again check and we will match this parity bit result in this result. So if they will match means our transmitted data and received data is correct. If they will not match means our transmitted and received data there are some error is there, right? So in this way we can check our transmitted data and received data. So there are some parity checker techniques, even parity checker or parity checker. And third one is by using XOR operation we can check. In XOR operation means this is the data. What we can do? 1 XOR 0, then XOR 1, then XOR 1, then XOR 0. Whatever the result will come, that will store in here parity bit and then transmit. And receiver side also we will do same operation. So in this way we can check this parity. Okay. And this even parity or parity we can use this technique to check this parity. So this is about the transmission process. Now So that's all about this UART and UART protocol and working process, and we study the framework of this UART protocol. Okay. Now let's take a break and watch this. We all are habituated to, in between, if we are doing any work, then we used to take break, right? And in that break we used to watch this. Now let's do these things here also. So this is one reel. We need to watch this. Okay, so this is one reel which I took from Instagram. So here they explain about how this UART protocol will work, right? So again I will show you and I will explain here. First, this first cat we can say the master, okay, and this second one is a slave. So this cat one want to transfer the data, okay, or else we can say master. He want to master want to send the data, okay. His slave or cat to say okay, you can transmit, like that. It is same. Then what is happening here? Here parallelly data is going on, right? This is the master. So this parallel data is going on. So what is happening here? Here parallel data came, right? And in this place they are adding stop bit, parity, start bit first, then parity bit, then stop bit, right? Then see, first which bit is going? Start bit is going, then after that data, then parity bit, then stop bit it is going. And how they are going? Serially, right? Okay, they reach here slave part, and again what is happening? The start bit separate, parity bit and stop bit separated from the data, and again this data will go parallelly. Let's see here. See, the data is going parallelly. Okay, now slave say I receive the data. Okay, so this is a good video which I found on Instagram to explain this UART protocol. So it is good to watch reels on Instagram, but the thing is what you are watching, that is important. Okay, so that's all about this UART basic theory, and in the next video we will try to study about the Verilog code for this UART. We will try to cover parts by parts. First code for the master, then slave, then baud rate. We will try to cover. Okay, so thank you, and if you like this video, then just share with your friends. Okay, thank you.